Hello everyone, myself Sanjana Singh, and today I'll be discussing about a subtopic under Automated Theory and Compiler Design, and the subtopic is Minimized DFA. So let's begin with the chapter. First, we'll be knowing what is the DFA. That is, what is deterministic finite automata. Deterministic finite automata is a mathematical model used in computer science to describe and analyze algorithms and trust processes. It is a finite state machine that accepts or rejects strings of symbols based on a set of predefined rules. Then, what's the importance of computer science? DFA plays a crucial role in various areas of computer science, including formal language theory, compiler design, machine pattern, and artificial intelligence, that is the AI. It provides a theoretical foundation for understanding and solving the problems related to automated regular expressions and language recognition. So, that was all about DFA. Now we'll be talking a topic that is minimized DFA. So before we move forward, we'll be knowing about what is definition of deterministic finite automata. A deterministic finite automata is a mathematical model used to describe computation. It is a finite state machine that accepts or rejects input strings based on a set of predefined rules and transition between states. A DFA consists of the following characteristics: a finite set of states represented by circles or nodes, an alphabet of inputs such as letters or numbers, a transition function that specifies the next state based on the current state, an input symbol, a start state, which is the initial state of the DFA, a set of accepting states which indicate whether the input of the string is accepted or not. So here we came to know that a finite states of states represented are by circles and nodes. A set of states represented by circles and nodes is called the finite state or the start state of the DFA. An alphabet of input symbols such as letters or numbers. That is, we can either give the input of 0 and 1 or A and B. These are the possible inputs that we give to the states. A transition function that specifies the next state based on the current state and input symbol. A start state, which is the initial state of the DFA. A set of accepting states which indicate whether the input string is accepted or rejected. What is the minimization algorithm? That is, in this topic, we'll came to know that how can we minimize the given DFA. That is, minimization means like we need to shorten the given data. Like if 4 states are given, we need to minimize it if possible. If it's not possible, we will not. But if it's possible, we will minimize the data. So the minimization algorithm states that it is used to simplify deterministic automation by reducing the number of states while preserving its functionality. The algorithm works by partitioning the states into equivalence classes based on their behavior and merging equivalent states. The algorithm works by partitioning the states into equivalence classes based on their behavior and merging their equivalent states. The equivalent states have the transition number for all possible inputs that lead to the same final or non-final states. So, the algorithm continues to merge equivalent states that no longer further merging can be done, resulting in a minimized DFA. So, 4 steps will include. We will exclude the states which are not required in the DFA. As they are also not taking part in the DFA, so we will minimize their data. Equivalent states have the same transition for all possible inputs that lead to the same final or non-final states. The algorithm continues to merge equivalent states into states until no further merging can be done, resulting in a minimized DFA. So let us move forward with an example. Here we need to minimize the given finite automata, that is deterministic finite automata. So here the states given are A, B, C, D, E and F. So total 6 states are given. The steps involved in solving the DFA consists of So let's move forward. There are 5 steps that can be done in solving this DFA. The steps includes, first we will need to remove all the non-reachable data from the start state. Here the start state is A. The arrow given determines that the state is the start state. So from the start state we need to check that all the states are reachable or not. So let's move forward. So here, the step 1, all nodes are reachable. So in the given example, we can move from A to B, B to C, C to D, D to E, E to F. Like from A, all the B, C, D, E, F states are reachable. Hence, step 1 is approved. That is, all nodes are reachable, so none will be excluded. If it happens that one of the state is not reachable, then we will exclude the node. Then, moving forward. For each pair of P and Q, where P belongs to Q and the small q also belongs to Q. The Q is nothing but the DFA. If P belongs to the final state and the Q belongs to the non-final state, then only we can mark the given data. That is, for each pair of P and Q and for each symbol of A belongs to alphabet, find transition of P of A equal to R and transition of Q of A equal to S. If the pair RS is marked in the table, then the pair will be marked. So we need to repeat this step 3 until all the states are reachable. That is, if in the given condition C, D and E are the final states. So we will mark all the states consisting of C, D and E. But we can't mark the states in which both the nodes are final. We can only mark those states where one is a final node and another one is a non-final node. So in the step 2, we will do it by constructing a table. In the table, horizontally, we will exclude the last node and vertically, we will exclude the first node. While doing this, we will construct a table. Then we will move to step 3. In step 3, we will write the transition function, 0 and the inputs. Like here, we are taking input as 0 and 1. So now we will consider the states which are not marked. Now considering A, comma B. Now we need to check A at 0, it's going to B, and B at 0, it's going to A. Here, both the states are non-final, so they will not be marked. Then we will move to A comma A at B1 it's going to C and B at 1 is going to D. Here, since both the states are final, we will also not mark. Remember, we can only mark the states where both of them are final. One is final and another one is non-final. If both are final, then also it's not valid. If both are non-final, then also it's not valid. But yes, when we are proceeding for the step 4, if some states, suppose here if we take the example of A and F, it's not marked initially, but if we check B and F, one is final and another one is non-final, that's why it's getting marked for C and F. So when we will be marking some state which is not marked here, if it is marked in the table like this in the step 3, it's marked, then we can also mark that in step 4. So by doing this, we will construct a table by marking and not marking. Or the whole table will get marked. Then now in the step 5, we need to combine all the unmarked states. Here the unmarked states are A, B, C, D, E and F. So we are getting 3 nodes which will help in minimizing the given DFA. So here we will take AB as one state, as one node, CDE as one node and F as one node. So we will get three states. Now the minimized DFA, like the previously existing nodes were A, B, C, D, E and F. Now we have only three nodes, that is A, B, C, D, E and F. So our DFA got reduced. Now we will combine all the unmarked state and reconstruct the DFA, which will look something like this. This is our final minimized DFA. The minimized DFA will consist of three nodes, that is AB, CDE and F. Since CDE were the final states in the given DFA, here also CDE will be the final state in the minimized DFA. Now we will look at the previous given DFA. Here we will also give the input of 0, 1 and 0, 1. Like on AB, the 0 is the self loop of the state. Like on giving 0, it will come to itself again. On giving 1 as the input, it's going to CDE. Same for CDE. On giving the input of 0, it's self loop. On giving the input of 1, it's going to F. And on F, in giving the input of 0 and 1, it's going the self loop. So that was all about minimized DFA. I hope you enjoyed the session. Thank you.